So again, this is a chunk of a larger circuit, so this probably just hooked up to a battery, but we don't care. What we want to find is the equivalent resistance. Now it looks weird, we've got 3 resistors, 2 of them are in parallel, and then this other like random 8 ohm resistor over here. So we're gonna start with things that we know we can do. And one of the things that I know I can do is I know how to add things that are in parallel. So I can do, for this little part, I can do 1/8 plus 1/8, which would be 2/8. And then that, if we flip that, okay. So we're gonna need that. So what I'm gonna do is I'm gonna redraw this circuit and include this equivalent resistance in place of these 2 branches, which are parallel. So let me draw this again. Still have this 8 ohm. And then now this has been replaced with this 4 ohm resistor. Okay, now, if I completely ignored what had been up here, and I just look at this, look, 2 resistors in series. So what am I gonna do? I'm gonna add them. So we get an equivalent resistance for the whole circuit of exactly 12 ohms. Done. Not too hard. Kind of fun. It's like a puzzle. I want you to try this one without me first, because I bet you can figure it out. And then, so pause the video, give it a go on your own, and then play it, and we'll see if we got the same answer. You can even skip forward to see what the answer was, and skip my solution and look at it only if you need it. So a lot more going on here, a lot more resistors, a lot of different scenarios, but I'm just gonna focus on things that I know how to do. First thing I know how to do is take 2 resistors sitting on the same branch in series and add them together. So that's the first thing I'm gonna do. And I'm gonna redraw this circuit as I go. So 60 volts. Oh. This is now just the 2 of these added together, which is 20 ohms. Okay, and this is 16. 8. Okay, next thing I definitely know how to do is add 2 things which are in parallel. So I do 1/8. We just did this in the last example, so this would be 2/8, flip it, it'd be 8/2, which would be 4. Okay, I know that math doesn't actually make sense when you look at it by itself, but you know what. Okay, so I'm gonna redraw this now. Okay, now I look at it. Oh, let me do this. I see something else that I can do. Aha, 2 resistors in series, so let's do that. Okay, cool. I got one more thing that I can do. These 2 are in parallel. I'm gonna add those, and then I will have found the equivalent resistance. And I think that's all they're asking for. It doesn't actually say on the paper. Yeah, it does. Yep, just the equivalent resistance, so we are good. And like, okay, 1/20 plus 1/20, 2/20, flip it, you get 20/2, which is 10. Let's not pull our calculators out for something simple like that. So we can say, in conclusion, the equivalent resistance is 10 ohms. big weird circuit. Lots of things we need to find. But first, this is a strange way to draw this circuit. I would not draw it this way if I was doing it myself. Why did they leave nothing here? Why didn't they like wrap some things around? Like why isn't this one like here or something to save space? You know, like why'd they do it this way? But anyway, that aside, I also find it confusing that they numbered the resistors instead of putting their resistance value on the picture. I think that's stupid, but we just need to be aware of stupid things like that so that we can catch them and handle them. So I'm gonna go through this list of resistance values that they give us, and I'm gonna put them on my picture in place of these numbers, because these numbers are confusing. And let me revert this back to its original format. So I'm gonna take all of these out, because they're confusing. And I'm gonna properly label them. So here we go. This is 2 ohms, 9 ohms, 19 ohms, 5 ohms, 7 ohms. This is a 12-volt battery. 1. That's a 1, not a 7. Looks suspiciously 7-like. 3 ohms and 5. Okay. Now, big and weird, intimidating, but it's just one step at a time. Just do something that you know you can do, and then look at it, and then do something else you know you can do, and then look at it. So you just keep redrawing the circuit until you get to the final answer, or until you've simplified it as much as you can, and then you work backwards. Now this is a problem that's going to take a while, and it's going to take a ton of space here. So I'm gonna put different parts on the board, but I am gonna have to erase the board and won't be able to keep it all on here. I suggest you get extra paper too, because that worksheet doesn't give you nearly enough room. I mean, I was able to squeeze it in on mine, but you need a lot of space for this, because you wanna be able to look back at it. Remember, these are your notes. Here we go. First thing I would like to do is, I'm gonna do one thing at a time, just to make sure everyone's with me. I'm gonna add these 2 resistors in series. Nope, I lied. I'm also gonna add these 2 resistors in series, because I feel like we're at the point where we can understand 2 steps at once. So I'm gonna do 2 and 9 is 11 together, 19 and 5 would be 24 together. So let's redraw this circuit. And this would be 11, and this would be 24. So I'm gonna redraw the circuit. Here we go. 11 ohms. This would be 24 ohms. This is still 7 from before. And then we got this. And I can already start seeing my next move here. Okay. What do you think? Next move? How about parallel branches? And again, I'm gonna do 2 steps at once. Parallel branches. Think we can handle that. So 1 over 24 plus 1 over 7. Add them, flip it, whoops. And over here, we're gonna do 1 over 1 plus 1 over 3, add them, flip it. Okay. And let's redraw the circuit. Moving right along here. So we've got, this is the 11 ohms from before. This is now combined. And what did I get for that? Oh, this is an ugly number, but I left it as a fraction just because we're in the middle of the problem still. So I get 168 over 31. Yeah. I just hate rounding in the middle of the problem. You guys know that by now about me. Okay, and then these 2 together, we get a resistance of 3/4. And 0.75 is terminating, so it doesn't really matter for that. It won't make a difference in like the accuracy of your final, because they're the same. Okay, nice. Oh, hey, look. I see a bunch of resistors in series. We know how to handle that. Yes, we do. We're just gonna add them all together. And we are basically, well, done the first part at least. And the first part was, let's find equivalent resistance. That's what I'm trying to do in case you weren't sure. Let's redraw this circuit one more time. And I'll put my unrounded answer and my rounded answer just depending on how you did it. You can see both ways. So this equivalent resistance is, well, exact is 2,749 over 124, which is not my favorite number. So let's just round that, and we end up with 22.17-ish ohms. Okay, so that's our first part. Now I've got to erase the board and move on to part 2, which will be finding the current at the battery. Okay. Welcome back. Part 2. Here's what we found in part 1. I'm going to continue to use this ugly fraction when I calculate further, but it was approximately 22.17. That's what we found in part 1 for the equivalent resistance. Now we want to know what the total current is. So what is the current at the battery? And at anything else which is in series with the battery. So Ohm's law, solve for the current, and this is total current and equivalent resistance. And we've got a 12 volt battery, and the equivalent resistance is this ugly. Remember, when you divide something by a fraction, you can multiply by the reciprocal. That'll get you the same thing, but we can just check our paper, and I get a total current of exactly, here's another ugly number, 1488 over 2749 amps, which is like 0.54. What else are we trying to find? That's it. Okay, we're done. So try those 3 practice problems on your own. I would show as much work as you can, take as much space as you can to make it as thorough as possible, because it's really easy to make little mistakes along the way. Not because you don't understand, it's just easy to do. And if you show more work, then you can look back and find your mistakes. So try practice 1, 2, and 3. Persevere in problem solving. If you get stuck, ask a friend, look on the internet, look back in your notes, but try to figure these 3 out. And even if you end up getting the wrong answers at the end, that's okay. We're still learning, and failure is all part of the learning process. So don't worry about messing up. Just try as much as you can, and we'll learn whatever we can.